Picture yourself stepping outside tonight and looking up, except this time there are two moons hanging in the sky instead of one. Not a trick of the light, not a reflection. Two separate worlds, both locked in orbit around your planet, both pulling on the oceans, the crust, and even the length of your days. This is what your life would actually look like if Earth had two moons instead of one. Start with the sky itself, because that is the first thing you would notice. Your one familiar moon, the pale companion that has hung there for over 4 billion years, would now share the darkness with a second body. Depending on how large that second moon is and how far away it orbits, it could look like a bright marble far off in the distance, or it could dominate half the sky, close enough that you can make out craters with your bare eyes. If this second moon orbited closer than our real moon does, it would appear larger and brighter than anything humans have ever seen in the night sky, second only to the sun itself. You would never again experience true darkness. On a clear night, shadows would fall in two directions at once, faint and doubled, stretching out from streetlights and trees like something out of a dream. Now think about tides, because this is where things get complicated fast. Your moon alone is responsible for most of Earth's tidal bulge, with the sun contributing a smaller pull that creates the difference between spring tides and neap tides. Add a second moon into the mix, and you are adding an entirely new gravitational tug-of-war. If the two moons orbited in sync, lining up with each other, and with the sun on a predictable schedule, you would get tides more extreme than anything coastal cities have ever prepared for. Storm surges would hit harder, low tides would drop further, exposing seafloor that is normally never touched by air. If the two moons orbited independently, on different paths and different schedules, the tidal pattern would become chaotic and much harder to predict. Coastal engineers would need entirely new models just to know when it was safe to build a dock or a seawall. You would also have to reconsider how you understand time itself. Right now, your calendar and even the word month trace back to the moon's roughly 29.5-day cycle. With two moons on different orbital paths, you would likely be dealing with two separate cycles running at the same time, one perhaps completing in a matter of days if it orbited close and fast, the other taking weeks or months if it orbited farther out. Ancient civilizations built entire religious and agricultural calendars around lunar cycles. With two unsynchronized cycles overhead, timekeeping would become dramatically more complex, and it is likely that early astronomers would have needed centuries longer to work out consistent, reliable calendars. Here is something you might not expect. A second moon would not just change what you see in the sky, it could change the stability of the planet you are standing on. Our single moon plays an underappreciated role in stabilizing Earth's axial tilt. That tilt, currently sitting at about 23.5 degrees, is the reason you experience seasons. Without the moon's steadying gravitational influence, models suggest Earth's tilt could wobble chaotically over millions of years, swinging between extremes that would make some regions unbearably hot at times and frozen at others. Add a second moon into this system, and the physics becomes far more complicated. Two moons pulling on Earth from different directions could either help stabilize that tilt further, or, depending on their masses and orbital paths, introduce entirely new wobbles and resonances that make Earth's seasons far less predictable than they are now. In the worst-case scenarios, the interaction between two moons and the Earth could become what physicists call chaotic, meaning small changes compound over time into wildly unpredictable outcomes for the climate. You also need to think about whether two moons could even survive together in the first place. This is one of the biggest challenges with the whole idea. Orbital mechanics is unforgiving when you introduce a third body into what is normally a two-body relationship between Earth and Moon. This is known as the three-body problem, and it is notoriously difficult to solve in any stable, lasting way. Two moons orbiting the same planet would constantly tug on each other as well as on Earth, and over time those gravitational nudges tend to add up. In most computer simulations, one of two things eventually happens. Either the moon's orbits become unstable, and one of them gets flung out into deep space, lost forever to the solar system, or the two moons are gradually pulled toward each other until they collide. If you are picturing that collision, do not picture something distant and cinematic. A collision between two moons in Earth's orbital neighborhood would create a debris field of rock and dust that could rain down on Earth for thousands of years afterward, essentially recreating the kind of bombardment your planet experienced in its early, violent history. If the two moons instead settled into a stable configuration, there are a few ways that could happen. They could orbit at very different distances from Earth, one close and fast, one far and slow, minimizing how often they interact with each other's gravity. Or they could share what is called a resonant orbit, where their orbital periods lock into a neat ratio, like one moon completing two orbits for every one orbit of the other. This kind of resonance is actually common in real solar systems. Look at Jupiter's moons Io, Europa, and Ganymede, which are locked into a precise resonance with each other right now. It is possible, though delicate, for two moons around Earth to find a similar long-term balance. Now imagine what this would do to eclipses. With one moon, solar eclipses are already rare enough that people travel across the globe just to witness one from the path of totality. With two moons in the sky, you would get a far stranger set of possibilities. Sometimes only one moon would cross in front of the sun, creating a familiar-looking eclipse. But occasionally, if the orbits align just right, both moons could pass in front of the sun at overlapping or separate times within the same day, creating double eclipses that no human in our actual history has ever witnessed. Lunar eclipses would also become more frequent and more complex, since Earth's shadow could fall across either moon or in rare alignments, both at once. Beyond the sky and the tides, think about what this means for life on Earth. Many species rely on lunar cycles to guide their behavior. Coral reefs famously spawn in synchronized events tied to the moon's phases. Countless nocturnal animals use moonlight to navigate, hunt, or avoid being hunted. Sea turtles rely on the natural darkness of the shoreline at night to guide hatchlings toward the ocean using light cues. A second moon, especially a bright one, would flood many nights with far more ambient light than these species evolved to handle. Predator and prey relationships that depend on the cover of darkness could shift dramatically. Some nocturnal species might struggle to survive in a world that is rarely fully dark, while others might expand into new niches created by the brighter nights. You should also consider how a second moon might have gotten there in the first place, because the method matters for how stable and how dangerous the whole situation is. One possibility is that the second moon formed through the same giant impact event that many scientists believe created our actual moon, when a Mars-sized body called Theia collided with early Earth. In some simulations of that event, more than one large moon can form from the debris disk, at least temporarily, before gravity eventually merges them or ejects one. Another possibility is that Earth captured a passing asteroid or dwarf planet from elsewhere in the solar system, similar to how Mars is thought to have captured its two small moons, Phobos and Deimos. A captured moon tends to be smaller, oddly shaped, and often unstable in its orbit, which makes the collision or ejection scenarios even more likely over long timescales. If you zoom out far enough, having two moons would essentially turn Earth into a far more dynamic and unpredictable system than the one you actually live in. Your nights would be brighter and stranger. Your tides would be more powerful and less predictable. Your calendars would be more complicated. Your seasons might be more chaotic. And hanging over all of it would be the looming physics of the three-body problem. A slow-motion countdown where the two moons are either drifting toward a violent collision or gradually working their way toward flinging one of themselves out into space entirely. It is a fascinating thought experiment precisely because it shows you how much quiet, unglamorous work your one real moon is doing right now. It stabilizes your seasons, drives the rhythm of your tides, and has done so reliably for billions of years, all without a second body around to complicate the balance. Two moons might look spectacular in the night sky, but the price of that beauty would likely be a far less stable, far less hospitable planet to call home.